我拿了一次上，你可以把我听懂。
Okay, now second session, we look at relative motion. What I mean by relative motion is that if you look at the diagram here, you have three objects, two moving objects, one stationary object. So you have two observers. One is fixed observer, which is usually your primary axis in the question. You have your x, y, and z coordinates, where it's fixed for you already. Means you don't change this one. Then you have two moving objects. Okay, you have two moving objects. One is B, which is the normal, previously what you analyzed, it is this B object. It moves in a certain way. Then there is one more observer, which is moving also. Then A referring, A looking at B, giving by a vector written as R B stroke A. How do you read R B stroke A? Position of B referring to A. Yeah. You read how you read this one. Position of B referring to A. And in my cheat code, I always like to write this one. RA. I read this one, I convert the slash into negative. All right, RB minus RA. This is the vector equation. In most of the textbook, they will give you a positive value one. They will give you RB equal to RA plus RB stroke A. It depends on what you want to, how you memorize. Some you memorize B here, A here, B stroke A. By way of memorizing for this kind of vector, is B stroke A, I convert the slash into negative. This is my way of memorizing, but you can use your own one. So here, position referring from your primary coordinate, we label as RB. A, this O, RB means location that you measure from fixed location. Same with RA means to refer to the fixed primary axis. And the references is A and B. So normally this R and B will be asked in the question where two moving objects, let's say two moving objects moving at the same speed, you're driving at the same speed, the relationship, the difference of vector will be zero because you see your neighbor also doesn't move, although both of you are moving. But if you're moving faster, this one slower, you will be seeing your object at your side will be moved to the back. Move to the back means negative velocity again, because it's opposite direction. Okay, same with if you slow down, this one move faster, you will see that you are actually moving in the back. So this is relative. This slash one is relative. So all is what I explained just now, and the observer, the translating observer will use axis also, but we label the axis as a prime or comma, y comma, z comma, x comma. Okay. So again, vector. If you look at this diagram, there are three vectors. You can complete the vector diagram. So this is one vector, two vector. Resultant of this vector and this vector is R B on this vector. Right? So you can remember RB equal to RA plus RB stroke A, or the one that I write on the whiteboard. I put this one as your subject, then B minus. Okay, same. So this relative position vector is always the focus of the question. That's in the assessment. We'd like to ask something about this. So this R, you know, is position. Position, we always change the velocity, right? How you change this one to velocity? Differentiate by time with R dot. Right? So this one, you differentiate by time, you get dBA plus dA squared. Okay. Acceleration also same, you differentiate this one, you get acceleration terms. Okay, vector, okay, undifferentiate, you get position, velocity. Okay, now let's apply what we learned in this interpretation. So a train travel constant speed 60 kilometers per hour. This one, the train cross over a road with this one at a 45 degree to the rail track. If the automobile A or the car A travel at 45 kilometers per hour along this road, determine the magnitude and direction of the velocity of the train relative. You see the word relative, it means you ask to find V stroke. Okay. Now, when you solve this question, you will see primary axis. Where is the positive? Where is the negative? To solve all your solution, all the direction to the x give you positive value, or motion moving up y direction is positive, right? And there's a relationship between this road and this track. Okay. Now, when you solve this question, you know vector. Vector, when you do in x, y coordinates, x is you use I, y you use j. So you have let's say you have vector A. You can write your vector A as yxi plus y a1 j. You can split your vector in x and y direction depending on the vector A itself. Right? Then here. You can solve this question by referring to x direction. You solve for x direction first, then you solve for y. How we do it? I use for vector analysis because it's more simple. I write the vector equation first. Because the question asked me to find velocity of train relative to automobile, I will write VT dot A. Again, I use my cheat code. I convert the slash into negative. Get this equation. Or you can write the equation of C of string. Same, huh? Same. So we can write VT equals to VA plus 3P squared. Same, huh? Same. So you use the I equation, to find the axis, right? So normally when I write the T stroke A equation, the next step I will revert back to what is the object. So you write this one and then we try to revert back to the term that is T in front, then A in back. Either one also same, but this one I solve for I direction data. So I change the velocity of my train here 60 kilometers. To the right is my x. So I convert 60i. There is no component in z because it's along x-axis. My z is 0. The right là plus 0z. Right? So what about your VA? Your VA is 45. And the angle is 45. You are given a vector with 45 degrees. This is 45 kilometers per hour. You can break into x and y between one. Right? So this component in x direction, this component is 45 cos 45. Okay? This one is 45 sine 45. Okay, we derive from your trigonometry equation sine cos sine and then we able to find where is the x. So your VA can break into two, like what I write on the whiteboard. Okay. You see, I'll show you on the slide here. You break the vector 45 into x and y. Then you can write 45 cos I plus 45 sin j for G. We don't know this term. We don't know the relative, which is what we want to find. Okay. Remember, this one also have I and j or two components. This, what you see here, is a resultant. You can break this one into x and y. So you combine the equation that we have on the screen here. I and I you combine together. Then j and j together. And here j is 0. Right? Then you get so, this one is in vector form. V straight relative to A is 28 I minus 31 j kilometer per hour. This is in vector form. Vector, you should know how to find magnitude and direction. This sample here do not show you the magnitude and direction. You should already know how to find magnitude and direction for vector. Okay. Okay, so this is what I'll show you. So you draw this vector into vector diagram. Positive 28i moving to the right, negative 31 move down because your y positive go up. You get negative means go down. Then there's an angle for you to find. This angle is referring to the track, horizontal track on your x-axis, this data. So basically, you're completing the vector diagram. You can find the magnitude. Square this one, square root. You get magnitude. Angle, you use trigonometry, either tangent, cos, or something, depending on the value you have. Normally, it's tangent. Right, so this is how we solve for this question. Next step. Next is we have two aircraft in a air show. So one aircraft here, plane A, is in a straight line. So straight line, it gives you what you learned in your linear motion. And plane B, you see there's a curvature, so it's a curvature motion. Curvature motion, you need to recall normal and tangent equation. Okay, you need to recall A equal to AN UN plus AT DG. Okay, normal one is what? Normal one will be V squared divided by rho. AT is what? V dot or undifferentiation of your tangent velocity defined. Okay, it's important, this one. Then you remember again, there's one more equation to find this one. I will pick one. Differential, etc. Okay, so if you see this question already give you the rule, so you don't need to count. Just substitute there, right? So we're having a radius also given. Determine velocity acceleration of V as measured by pilot A. So how do you write the vector, relative vector? Measure at A from where? A dot B. You measure from A. So you transform this one into negative one and you revert back. Okay, depending on what we want to find. Huh? So velocity, what? Velocity is given here, 700 kilometer per hour move up. VB also same, move up 600 kilometer per hour, you have two vector. And this one is a straight line vector, it's not a triangular vector that we usually see. This is a straight line velocity. What is the relative velocity here? The arrow should be point up or point down to complete this vector diagram. the two vectors go up. Usually, your relative, or you imagine you are A and B, you are competing. You are moving faster than B. Because the vector line here on the screen here is longer, you're moving faster. 700 and 600. You'll be seeing what? Relative, you're seeing B. Move front or move back? Move back. Arrow will be pointing back. The relative velocity, if you see your neighbor, will be moving back. So the vector will be pointing down to complete the vector diagram. The vector total will be 0. Okay. Right. Now, vector diagram, you always start with first vector, second vector, and then the resultant always take the start and the end. Same with this one. So the start and end where? You always pointing to the end. Write the equation. You can write the A stroke B. This one is B stroke. It should be A stroke B or up. It should be A stroke B. Okay, the notation that you see on the screen here is a bit wrong. It's not B stroke A, it's A stroke B. A stroke B because it's measuring from A. Yeah, take note on this one. There's a mistake in on my side. Okay, it's not B stroke A, it's A stroke B.
So, I thought that one is B with respect to say
Measuring from this one is referring to from B to A. This B to A. B to A. B to A. So then that. This one is observe B from A. B from B from A. Okay. Then correct up and such like that. Then my start correct. Then the shift to automatic from train, and this one correct. Okay, then my start correct. Okay. Then you substitute the value. You get B stroke A. B from A is negative, 1 negative because it's going back. It's going back. From the diagram here, the 1 is going forward to positive. Acceleration still the same. Acceleration, remember, go back to the diagram. This is a curvature. Curvature, you have normal and tangent. So normal pointing in, tangent go up, right? So we know that from the equation to find the normal component is B squared divided by rho. B squared is given 600. The tangent velocity 600. You get normal. Then you substitute back acceleration. AB equal to A plus AB stroke A. Substitute BB. BB is 900 minus 100. This one is what we found just now. Oh, sorry, from the diagram. This one is 100i negative because it goes back. So 900i is what we found. So just to take note, when you see curvature, you need to find normal and time. Then A is 50, is given in the diagram. J, then you solve, you have I and J, you put I and J together, you get the relative. Okay, the acceleration, relative acceleration. Okay, here you can find magnitude and direction. Square this one, square root, you get an angle of 60. This one is slow down. Okay, with this we complete chapter 1. Okay, we stop the recording.